So I'm here to talk to you about Doltgres. I'll get into what that is and what that means and why it's such a strange name as we go. But first, I'm Tim Sehn. I'm the founder and CEO of Dolt Hub, which is the company that builds Dolt and Doltgres. And I'm going to handle like the first 5-10 minute intro, and then I'm going to hand over the screen to Zach, who is basically our Doltgres lead. He didn't start the project, a guy named Dalen did, but I think he's kind of taken over and kind of more running point and leadership on how it's going. And so we've been in business for 7 years. We have a number of products, and Doltgres is one of them. But we're still a small company. We're 16 people. Zach's in Seattle. I'm in Santa Monica. We have a person in Oregon. We have a person in Paris. We have a person in Philadelphia. But most of the center of engineering is in Santa Monica, which is Los Angeles, and Seattle. So we're joining you from the West Coast of the United States. And with that, I'll kind of explain what we do. So our first product is Dolt. Dolt is the world's first version controlled SQL database. And so if you've used Git and you've used a SQL database, in Dolt's case, MySQL, just imagine if those two things had a baby, and that would be Dolt, the product. So you get all of the features of a SQL database, transactions, create tables, multi-table joins, constraints, foreign keys, all the things you know and love about SQL. But everything in the database is version controlled just like it is in Git. So all the operations that you would do with Git on files are now available to you on SQL tables. And this includes schema and data. There have been a few other products. Liquibase is kind of one of them that offers some sort of version control on schema. We are the only database that offers version control of data at scale. This means branching, merging, diffing, all of this stuff. And I'll explain how we do it. It might seem impossible, but the reason we've been in business for 7 years doing this is because it's kind of hard. So you get log, branch, merge, diff, clone, push, pull, all the SQL, all the Git idioms you're used to in code. You get those on SQL tables and files. Now, in SQL, the get read operations like log are exposed as in Doltgres they're exposed as system tables or functions, and the write operations in Dolt are exposed as procedures. In Doltgres, that's functions. But so where you would run git log on the command line, you would select star from Dolt log. In SQL, when you would say call Dolt, when you would say git commit on the command line to create a commit, you would call Dolt commit in Dolt. So very similar interface. First question we often get is why is it called Dolt? It's just kind of a strange name for a product. When we were very inspired by Git. So the idea is that Git means idiot in British slang, and so we needed a word that meant idiot that started with D for data that was short enough to type on the command line. So we thought for a while and came up with Dolt, and it kind of stuck. And we like quoting Linus Torvalds, saying that he names all the products after himself. So I guess so do we. We're a bunch of Dolts. So how do we do that? The interesting thing about Dolt is Dolt does not have any Git or MySQL code in it. It is built from the storage engine up to provide this functionality. The core data structure that kind of the whole thing works on is a novel data structure called a Prolly tree. I have one labeled here. A poly tree is a content addressed B tree. And so Postgres, all of its tables are stored in B trees. Um, the the idea is, with the problem with B trees for version control is if I insert 1, 2, 3, 4 and Zach as primary keys and Zach inserts 4, 3, 2, 1, generally on disk, those B trees will look completely different. You do not have the same database. In a Prolly tree, there's a bunch of clever algorithms that make it so that if that inserting 1, 2, 3, 4 or inserting 4, 3, 2, 1, or basically inserting in any order will produce the exact same tree on disk. And what this allows you to do is then give each tree a content address and various portions of the tree as well. And then you can, and so you basically make a content address based on the contents of the keys. And then you only have to store each, we call those chunks. You only have to store each chunk of the table once. So you get history independence, which is very important for version control. That's the idea that 1, 2, 3, 4 and 4, 3, 2, 1 all end up in the same tree. You get structural sharing because now each chunk can be given a content address, then stored on disk and addressed by that content address. And then finally, you get fast diff because if the top of the table, if the table hasn't changed, it has the same content address. If someone asks you, has this table changed? You look at the content address, it's the same. You say, no, it hasn't. If it has, you walk the tree looking for, walk both trees looking for content addresses that have changed. And so if only one row is changed, one of the leaf nodes down on, let's say, down in one corner, say, will be different. You can ignore the rest of the tree and walk very, very walk very quickly down and find the diff. And so comparing, the other piece of version control that's very important is comparing these two, two versions, because that's what's used to merge, and a bunch of other version control operations. Even just you call get diff and want to see what changed, you can call Dolt diff and see what changed. And so just imagine what this data structure right here is, represents a table with primary keys 1 through 21 as integers, and the actual values of the rows are dangling off each of these 1, 2, 5, 6. Now these are the values of the rows are dangling off here, and that's how we represent a table. Now, when these get to be like a billion rows, each chunk in reality is about 4 kilobytes, and so they never get to be like more than 4 or 5 layers deep. And so now I think a lot of people may be asking, well, how databases contain more than table data? How is that represented with a content address? Well, so the table data sits over on this right. Oops, sorry, I'm touching my mouse. Oops. This table data exists in this tree on the right. We then create a schema in the same Prolly tree structure, so it gets a content address, and then we hash the content address of the schema and the context of the data together to create the table. All the tables in the database are then hashed together to create a root object, like a root content address of the database, and that's what goes in your commit log once you mesh it, like you hash in some commit metadata, just like Git. And so the idea here is we have a novel data structure. It's called a Prolly tree. This is why we had to build this thing from the ground up. It's the only way we could get version control to work. It's also the reason we're the only people that do this. It's kind of hard to do. It's novel computer science. So now we didn't build the whole thing from scratch. We leveraged some open source packages. We use Vitess for parsing. Vitess also provides this horizontal scalability utility. We actually have a fork where we threw out all that part. We don't use it at all. We just use the parsing. We took over a project from another company called sysd, called Go MySQL Server. That was a pure Go MySQL compatible engine. That's the reason Dolt is MySQL. No Postgres equivalent existed. And so now so we were early contributors to this. The company that was supporting it went out of business, so we took it over, and now it's a pretty popular package. The noms, which is what the storage, the original storage engine, which implements the Prolly tree. The company that was supporting that had gone out of business, so we took that over, and that was written in Go. So we needed a Go package to provide SQL support. We were debating between doing it in Postgres or not. We found Go MySQL Server. We thought this is the most expedient way to get to SQL, and thus Dolt is MySQL. This was in the 2019, 2020, 2008, end of 2018, early 2019 era. So I'd say MySQL is still a little bit more popular than it is now. Now, clearly, as we are sitting here in the Postgres meeting, Postgres has kind of won the hearts and minds of the open source community, and so
We agree.
yeah, I don't think obviously I'm preaching the choir, but I don't think any rational person would disagree at this point. Anyway, so we're an agglomeration of basically three open source projects, two of which we are now the de facto owners of. And so basically, Dolt is a MySQL compatible server. You connect to it with MySQL client, but there is no Git or MySQL code in it. It is completely our own custom Go code. How do you use this thing? So we have three kind of primary use cases. The first is, and I'll go through kind of our reference customer for each use case. The first is as a machine learning feature store. So Flock Safety is a company out of Atlanta. Actually, I heard they were going to IPO soon. We started working with them when they were about like 10 people. They're up over 400 data scientists now. They hang, now that you've heard about them, you might see them. They hang cameras in neighborhood associations, buy cameras for your neighborhood, and then what happens is if it basically it's infrastructureless, it's just a camera with a wireless modem, and they do anomaly detection on cars driving your neighborhood. So they'll be like, these are, if a house gets robbed, they're like, these are the three houses, there are three car license plates that were in your neighborhood that aren't usually in your neighborhood, and police go and solve the crime. And so they're pretty popular. I think they have a deal with the city of Las Vegas. So if you ever go there, you'll see them. But they store all of their machine learning training data in Dolt. So they initially used it for model reproducibility, but now they use branches to add audio. They really love the explainability aspect. If they cut a model, they create a Git style tag. If tomorrow's model performs worse, they look at the diff in the data, and they've said that they've been able to find problems in their model that would have taken them months within minutes just by looking at the diff of what's changed. So they're pretty happy customers. The second set of customers is video games, which is kind of odd to us. We never really was expected this, but modern games have like hundreds of gigs of configuration. Like every object in the game has basically like a YAML or JSON file associated with it. Most video game companies start by storing these in Git, and what happens is they can't end up not being able to find anything. They're like, I need to be able to change increase the damage of every sword, and that takes forever, and so they have a choice of abandoning version control and putting that stuff in a database, or staying in Git and having all these discoverability problems. Dolt just kind of gives them the best of both worlds, and they end up using them. So Score Warriors, a company, they build a sort of a mobile game, and they're our first reference customer here. But we've closed deals with a number of the large players in this industry. So that's going well. The final one, and this might be interesting, the Postgres folks on this thing, is if you want to add a pull request or branching workflow to your own application, Dolt is often a very expedient way to do that. FJ is this company in the United States that builds basically insurance plan management for healthcare, and so they white label Dolt as the backend for the application, and then it exposes branches and a branch and merge workflow to their customers of their application. So they don't the customers know nothing about Dolt. They just get branches and merges. Like basically, I want to create a new set of a new plan. I'm going to do it on a branch and then have it reviewed by someone else. And so adding this pull request workflow, which kind of leads me to our most exciting kind of new use case. And this is brand new. We think that basically agentic workflows. If you use Cloud Code, the reason you're willing to let Cloud Code write code for you is because the code it's operating on is in version control. You can have it do it on a branch. If it does something stupid, you throw it away. We think Dolt and Doltgres can bring that capability to basically any application that's backed by Dolt. In fact, I was talking to a founder on Friday of a popular analytics platform, and he was like, "I would never let agents make dashboards through an MCP." And I'm like, "Well, what if you just stuck the metadata in Dolt and then they did it on a branch? Like, what would be the downside?" And his eyes kind of lit up. He never thought of it that way. So we're really excited about this use case, and so we think if you're interested in adding like MCPs or agents to your application, we think Dolt or Doltgres is a good way to do that. But it's MySQL. So I talked a little bit about why we ended up on MySQL as a format. Really, it is only like the wire format and SQL dialect that we support that you're using. You're not adopting any of MySQL's like storage engine or tech or binding yourself to the community other than the client. So we had this image didn't scale very well, but so we had a lot of Postgres people come and say, "Hey, I wish this was Postgres." So Dolt launched in 2019, and basically over 3-4 years, basically people would show up and say, "I wish this was Postgres." And so we finally got enough slack. Dolt was working well enough that we decided to fund a project to make Dolt Postgres compatible. I'm sure you all know, but Postgres, the SQL dialect is, now that we're into it, is probably 2 or 3 times bigger than MySQL's. Like there's just a lot of features in Postgres, a lot more functions. Like you can there's row types. There's just a bunch of different stuff, extensions even. It's been a bit of a journey, but we started working on Doltgres in 2023. We had an alpha version in fall of 24, and we went beta in April. So we have a product in market. I'd say if you pick it up, and Zach will talk more about this, but if you pick it up, it's you probably will run into bugs even importing a dump, and so you're going to need to work with us to support your schema, but it is functional and we can make it work for many applications. So with that, I'll hand it over to, now that you've kind of heard the journey and kind of know how it works, I'll hand it over to Zach and he'll talk to you a little bit more about how it works, how it's built, give you a demo and all that good stuff.
Thanks. I was just going to ask a question while we're kind of transitioning, and you may have covered this and I just kind of missed it. So does Dolt connect to Postgres as a server resource, or is it like,
No, it's a standalone database for like the way you can use it with an existing Postgres is you can set it up as a replica.
Got it. Okay.
And so then what ends up happening is every transaction commit in your main Postgres or your primary Postgres becomes a Dolt commit in Dolt or in Doltgres, and so you end up getting basically an immutable log, a diffable online log of every transaction.
And then what are the deployment models for like, are you guys cloud only? Like, do you guys?
No, it's free and open source. You download it and you run.
Okay, so people can just like roll their own.
Yeah,
they can just like go in like EC2 and just roll their own Doltgres and connect it as like a read replica to an existing Postgres. Okay.
Absolutely. Yeah, in fact, we think that that's the best way to use it at the start. We think it is powerful enough to run an application, not a really large scale one, but most like 99% of applications is probably fine. But yeah, I think the best if you're like, huh, that's interesting. And the way we recommend kind of dipping your toes into the water is by running it as a replica. Yeah, it's free and open source. You just download it, you run Doltgres, and you get a MySQL compatible or a Postgres compatible server running on port 5432, just same as Postgres. Same authentication, same everything.
Thanks, Tim.
Hey
So
Tim, is it production grade or it's still the beta version?
It's still beta. Dolt we have it's the same engine, and Dolt we have like hundreds of people running it. We have like
many hundreds of customers. Uh-oh, we lost
We
Tim.
may have just lost Tim.
It's okay. He'll come back. So
All
I'll take over in the meantime. I'll address the question of what beta means in the context of Doltgres and when we'll get to 1.0 and so on. I should start by clearing up a frequent point of confusion, which I think Elizabeth just echoed. Like, what is the relationship of Doltgres to Postgres? Is this like an extension? Does it connect to a Postgres server, etc.? No, it's a standalone database. So you should think of Doltgres kind of in the same vein as other Postgres compatible databases like Cockroach, for example. Things that implement the Postgres wire protocol and the Postgres dialect so that you can connect to them with anything that speaks the Postgres dialect and wire protocol, any Postgres library or workbench or anything that you could connect to Postgres. You can also connect to Doltgres. Your tool just thinks you're talking to a Postgres database. It doesn't know that it's talking to something that isn't Postgres because we emulate all the same semantics and wire responses, etc. Can people hear me? I'm just making sure I'm not also
Yep,
dropped
you're
off.
rolling. Good job.
Okay, thank you. Thanks. So yeah, so it's you think of it as Postgres compatible as opposed to a true like it's not like some databases like Neon where it's actual Postgres running in the background. It's emulated Postgres so that your whatever client or application you're connecting to thinks it's talking to Postgres, but it's actually talking to Doltgres under the hood. So like Tim said, we've been doing this for about 7 years now. I've been at Dolt Hub since almost the very beginning. So I was heavily involved in the development of Dolt, and now I'm leading the Doltgres project. And so we've been working on the like Tim mentioned, a lot of people when they initially expressed interest in Dolt said, "This sounds really cool. I want a version control database, but we don't touch MySQL. We're a Postgres shop." And we heard this more and more as time went by. I like Tim said, we're preaching to the choir. Postgres is the new open source database that everyone's building new projects on. MySQL is increasingly legacy. No one's building new stuff on it. And so it became clear to us that if we wanted to attract this new application development, we have to kind of meet developers where they live and offer a Postgres compatible solution. So even though Dolt doesn't have any MySQL code in it, it's still to use it, you have to speak the MySQL dialect, you have to use the MySQL toolchain and all the MySQL libraries and so on. And people don't want to do that. They want to use the libraries and toolchains that they already know about, and people use Postgres now. So that was our motivation for offering this Postgres compatible version. It is now beta quality. It took us about 18 months from when we started development of Postgres to get to what we consider a beta release. Our bar for beta quality is that we think that for most customers, if you take your existing Postgres dump and import it into Doltgres, it'll just work. You can run your existing Postgres application on Doltgres without any code changes. That's kind of our bar. That's not going to be true across the board because it is beta quality. Where it takes a long the long tail of errors that customers are going to encounter are going to take a while to iron out. But we want people to we think it's good enough that you can start trying it and seeing what works and what doesn't. And if things don't work, typically we can fix issues within 24 hours. It's kind of a point of pride of us that for us that we can turn issues around really quickly, and we want people to use it and tell us what's wrong. So I want to talk a little bit about the architecture of the system. Tim mentioned that we built this from the ground up. And we had to do this because it does use this novel storage engine that we need in order to implement these semantics of fast diff and merge. It's not possible to start with Postgres and then build version control on top of it. You actually need the data physically stored in such a way that makes it possible to diff two versions of the database efficiently. That's kind of the magic of Prawley trees. That's why Dolt is possible. So we did build it from the ground up and then kind of built a SQL engine on top of that. The first version, like Tim mentioned, was MySQL compatible because that's kind of what we got off the shelf. And now we're building out the same functionality for the Postgres side of things. So here's the architecture. This is the big 30,000 foot view of how Dolt works. And I'll switch to a version with some annotated boxes around it. So on the right-hand side, outlined in blue, that's the Dolt storage engine itself. This is where the tables and all their rows and their schema and everything you store in the database is defined, as well as all the business logic that knows how to diff two revisions of the database, merge two branches together, etc. All that stuff lives in the blue box. That's kind of the Dolt core. And this is completely shared between Dolt and Doltgres. Moving one layer higher up the stack, we've got this Go MySQL server project, which, like Tim mentioned, we inherited from a company that went out of business. And this is a pure Go implementation of a SQL execution and query engine, which was originally handled only MySQL dialect, and we've now extended it to also handle the Postgres dialect to support Doltgres. But the cool thing about this engine is that it's backend agnostic. So it defines a set of interfaces in Go, and different integrators can define their own backend to their own data sources and use the query engine to query whatever arbitrary data sources that they want to. So we did this. We have the most complete implementation, which is Dolt itself, Dolt and Doltgres. But other companies have recently started to implement those same interfaces themselves to implement their own backends to query their own data sources. It's been really cool to see that happen. So the Go MySQL Server project itself has a life independent of Dolt and a growing user base as well, which I think is really cool. So then the top layer, we've got these two front ends. So in orange, the MySQL front end, that's powered by Vitess, which is originally what made YouTube work. And it now powers PlanetScale. We have a fork of that, and that handles all the MySQL parsing and wire protocol semantics. For Doltgres, it doesn't use the MySQL front end, of course. It uses the Postgres front end. We took our Postgres parser from Cockroach, which is another Postgres compatible database, but not Postgres itself. So we parse incoming Postgres queries into an AST representation, and then we have a set of library utilities which convert that AST into into the Vitess AST so that we can hand it off to the SQL execution engine. And from that point forward, with a couple exceptions, the SQL engine itself doesn't really know that it's handling a Postgres request versus the MySQL request. It's just processing this query that's represented by an AST, and it's going to get, and then there'll be some handling on the other side to transform it into the right format on the way out. And it's because of this shared code base that we feel comfortable saying that Postgres should just work, because as long as we have that parsing and translation aspect correct, everything else works the same between Dolt and Doltgres. And at this point, we've got thousands of customers on Dolt running, many hundreds of applications running in production. So we're very confident in the correctness of the engine. It's really just that there may be some incompleteness, or we may have made a mistake in the translation, but for the most part, everything should just work. So I mentioned it took us 18 months to get from Dolt to Doltgres, and this is because Postgres is just a much larger product than MySQL. And this is strange to me because when I started my career, MySQL was the clear front runner. Postgres was kind of this weird, chunky open source academic project that not a lot of people used, didn't have a lot of features. And now 20 years later, it's exactly the opposite. MySQL is stagnating, and Postgres has added all these features which developers have come to rely on and consider essential. And these are just things that they don't exist in MySQL. So we had to kind of build our own implementations of them from scratch in order to provide support for them, because we found very early on that Postgres customers really do use these features. They're kind of table stakes to getting any existing Postgres customer to even consider using the product. So here I'm talking about things like schemas, sequences, all the types that Postgres define, and people use a lot of the types that Postgres defines, including array types and JSON types and all these things. And again, these are things that just they don't exist in MySQL at all. A big stumbling block for us kind of early on, and we're still ironing out all the kinks in this, is the PG catalog tables. PG catalog is a system schema that Postgres gives you by default, and it kind of stores and vends all the metadata about your tables and their schemas and their indexes and all the stuff that's in the databases. This is really important to get right because different libraries and tools will issue queries to these PG catalog tables to figure out what's in your table. So a workbench will ask the PG catalog tables what tables exist, what their schemas are, what sequences exist, and so on and so forth. It's a huge surface area, and it was very complex to get working. We had to do something similar for Dolt originally with the information schema tables for the same reason. PG catalog is even more complex. It took a long time to get something kind of beta quality out the door. As an example, SQL Alchemy, which a Python tool that kind of is a ORM for Python, transforms your SQL objects into Python objects. That tool issues something like a dozen queries to the PG catalog tables, many of which include like 5 or 6 table joins every time you load up a SQL Alchemy program. And so if any one of those pieces wasn't working exactly correctly, the same way that Postgres does, then that tool just doesn't work. So we made a lot of progress on that. We've gotten a lot of we close a lot of that ground. We do think that there are still gaps, and we need customers to run the tool and help us find them. Like Tim said, it's free and open source. We expect most people are going to run the program on their desktop. You can spin up a cloud version, of course. We have a pretty cheap option if people don't want to host it themselves, but you're always free to do that. So real quick, I'm gonna walk through kind of what a query looks like internal to the engine. Again, this is just to give a kind of a taste of what the query engine is actually doing at this layer. So query starts by parsing, and this is just the process of taking that query string, select star from whatever, and translating it into an abstract symbol tree so that we can then further process it and analyze it with various algorithms. That's what the parsing phase does. From there, once we have an AST to work with, now we need to take all the references that are in that AST, the names of tables, columns, functions, etc., and bind those things to actual concrete implementations that can return data for us to work with. So here we have three queries, one that references just a table, one that calls a stored procedure, and then one that calls a table function. And these things are all defined as different interfaces in red on the left, that are then implemented by Dolt and Doltgres to vend that information to the query execution engine so that it can get the raw data back and ultimately return results to the customer. And here it's just kind of spelled out a little bit differently. SQL.table interface declares a table, and then Dolt implements a version of that. SQL.table function declares table functions, and so on. So once we've bound everything into a query, we know all the tables that it references, the columns it references, et cetera, exist, and we can get data back from them. Then we go through a process of simplifying and optimizing that plan in order to get better performance. A real simple example here is that if you have a select statement that includes only a subset of the columns from the table, you can save a lot of memory bandwidth by not spooling the entire row from disk, only spooling just the columns that have been asked for back to the query engine because it doesn't need anything else. So here we have an interface called SQL.projectedTable, and Dolt implements this, of course, and that lets the engine tell us, hey, we only need these 2 columns from the table. When you're spooling table rows back to us, only include those 2 columns because we don't need that. And again, doing this is a massive speed up because of the decreased memory bandwidth required. Lots of other optimizations are necessary. I'm just going to go over one more briefly. If a table is being addressed on a primary or a secondary index, obviously it's much faster to use that index to go directly to the row or rows that are being requested rather than scanning the entire table. And so Dolt, of course, implements these semantics with the SQL.indexAddressable interface there, in order to, again, just tell the table, hey, I only want this one row. When you give me back rows, only give me the one that I'm interested in. After the set of basic optimizations, then we go into join planning for queries that need join planning. I'm just throwing this complicated diagram up on the screen to show you that this is a topic of a lot of research and hard work over the last many years. You could do several hours just on this topic alone. All I'm doing here is saying this is really complicated. It's been a lot of work, and we put a lot of effort into it in order to get our performance very close to what MySQL implements. We're proud of that. Finally, we've got an instantiated query plan. It looks like kind of a tree of nodes, and we can start getting row results back from that. And that looks in practice like a bunch of nested iterators. So here's a query plan represented as a tree, and the green boxes are iterators. So at the very base layer, we're spooling rows from the tables into this one layer up the stack, this next iterator, which is a join, that's going to assemble those two table rows together into one result row, and then finally pass it to a projection, which is going to evaluate different expressions on the results of those columns, and finally return it to the user. That's what a query looks like front to back. That's how the SQL engine executes it. Hopefully that didn't take too long, because I think that the part most people are more interested in is what does it mean for a database to have branches? What does version control means on a database? Tim touched on this briefly. I'm going to go into it with a little more detail, and we're going to end with a demo that should make it very concrete about what the value proposition is for having version control on a database in the first place. So this is where Dolt and Doltgres are very different from a traditional RDBMS like Postgres or MySQL, which is that Dolt has branches. So this diagram, all the little smiley faces you see at the bottom represent users, and these users are connected to different branches on the same database. So one database server, many different branches, as many users as you want can connect to each of those branches, and they all see a different version of the data because they're all connected to different branches. Or not necessarily different versions, but whatever version of the data is pointed to by those branches, just like you would expect with Git. If you check out a branch, you see a different version of the code. The same thing is true with Dolt. So you connect to the branch you're interested in, you're going to see the data as it existed on that branch, and you can make edits to that branch, which you then will eventually merge back into main. So there's different ways to connect to a branch, kind of from top to bottom at the bottom of the slide here. First is to just give a connection string, so you can include the name of the branch in the database you're trying to connect to, and then every client that uses that connection string is going to start their session connected to that branch head. Inside of a session, you can change the branch you're connected to with the Dolt checkout function. So I select Dolt checkout and the name of a branch, and now my session is connected to that other branch that I named. I can also just reference the name of another branch's tables with the same fully qualified database syntax. So mydb/feature branch. And I can then qualify that further with the name of the table. And now instead of the connected branch, I'm inserting into this other branch's data. And then finally, we implemented this SQL extension declared in like 2011 for temporal tables. We use this feature not for temporal time travel queries, but for version control queries. So if you use the as of syntax and give it the name of a branch, or anything that points to a commit like a hash or head tilde, you're going to be selecting from or inserting, etc., from those tables as they existed at that particular revision. So Tim mentioned that we copied Git for our interface, and we really kind of stuck to this as our iron principle, our North Star for the design of how the version control features should work. The idea is that if you know how to do something in Git, you can just do that exact same thing in Dolt or Doltgres without reading any documentation. So it's just a direct literal translation. So in Git, to add a file to the staging area, you type git add my file. In Dolt or Doltgres, in SQL, it's the same thing, except you're calling a function. So you're going to select Dolt add and then the name of the table, and it accomplishes the exact same thing, same exact semantics. And there's a bunch of examples on the page here. Like Tim mentioned, the write operations for version control are modeled as either stored procedures or functions, and the read operations tend to be modeled as various system tables. So if you look at the equivalent of typing git log shows you all the commits going back to the beginning of time on your current branch. To do the same thing in Dolt or Doltgres, you type select star from Dolt log, and that shows you a list of all the commits that are on your current branch. Same exact semantics. And again, our goal was that if you know how to do something in Git, it just works the same. You don't have to read any documentation. We're trying to leverage developers' existing understanding of how these tools work in order to teach them how to use the product without reading a bunch of documentation. Okay, so now we understand the basics of how this works. We're going to jump into a demo. And this demo is meant to be a really simple demonstration of how our main customers are getting value from the product, which is to say, it's a collaboration and version control use case. So two developers make changes on different branches, and then they want to merge them back into the same main branch. So I'm going to go ahead and 1 second here while I change what I'm sharing to share my terminal instead.
Real quickly before you start your demo, how are you doing on time? I think we're gonna go over the top of the hour.
I think we are. The demo is only about 5 minutes, so I'm
Okay.
close to wrapping up. Yep.
Great. And you can hang out for a bit. So yeah, if somebody has
Definitely.
to, thanks for dropping in. We'll see you soon. And if you're able to hang out till the end of the demo and for some questions, it sounds like Dolt will hang out for a bit.
Yep, we'll hang out as long as people want to keep talking to us. So on the command line, Doltgres is just a binary you download. You run it with the Doltgres command, which I'm doing now. I've got debug enabled so we can see all the queries that are coming into the database. And then you connect to it just like any other Postgres client. So here I'm using the pSQL tool. I can see that I'm connected to a show databases is an extension that we implemented, so we don't have to use the cumbersome slash commands in pSQL. So I can see that I have a couple databases here, information schema and Postgres. That's great. I'm going to now connect to this thing and import a little SQL script that I have prepared, cities.sql. I'm going to pipe that into the pSQL command, and you can see that it ran a few statements. So here I'm creating a new table to kind of modeling cities, what state they're in, what population they have, and then inserting some values into it. New York, Chicago, Los Angeles. And then finally, I'm calling select Dolt commit with these arguments that creates a new commit as of that data that I just inserted. And you can see that the result of that commit is this commit hash, which you can note down if that's part of your application logic, but you certainly don't have to. Okay, so now we have we've created a main branch. We've got a table and some data for that table. So now we're going to do the same thing on two different branches. So here I'm running the Houston.sql branch. And this script does three things. So first, I'm creating a new branch and checking it out with the Dolt checkout-b option. So I'm creating a new branch here called Houston, and you can see that the result says I've now switched to the branch Houston. Again, this works exactly the same ways if you're making changes in Git. And then I'm going to do a couple inserts and updates. So I've added updated the population of Los Angeles, and then inserted the city of Houston, and then finally call Dolt commit and get back this commit hash as a result. So finally, we're going to do the same thing. We added Houston on one branch. Let's add Phoenix on another. Exact same thing. New branch, insert some data, update some data, commit the result. Okay, so now let's connect to the database again. And now if I select star from the cities, you can see that I'm on main. So I have my initial set of cities. Nothing has changed on the main branch, and that's because I made those changes on two different branches. So main doesn't reflect those changes that I made on those other branches yet. And if I want to see what those branches are, I select star from Dolt branches. And here you can see I've got these my main branch here, and then the Houston and Phoenix branches that were created by those scripts. So let's go ahead and merge them in. I'm going to merge the Phoenix branch first. You can see the operation was success, merge successful as part of the result there. And then I'm going to go and do the same thing with Houston. Okay, so that all worked. And now if I select star from the cities, you can see the new data that I inserted as well as the data that I updated. So both those changes from those branches merged in successfully. And if I look at the log by typing select star from Dolt log, you can see the commit history here. So here's the initial commit on main where I imported the cities. And then here's the commit from one of the branches, the commit from the other branch, and then finally a merge branch. So the first merge that I did was a fast forward because there were no intervening commits on the target branch. And then the second merge that I did created a merge commit because it wasn't able to do a fast forward. And again, the semantics here work exactly the same as Git. There should be no surprises to anyone who's ever done their own Git merges. So the final feature I want to show before we take questions is the diff capabilities. So this is the other kind of unique feature of Dolt is you can very efficiently examine what's changed between two revisions of the database. So here I'm running a select statement involving this Dolt diff table. It's actually a table function, so I'm giving it arguments. I'm telling it I want to diff the previous commit with the current head for the cities table, and I want to select some but not all of the columns there. So here's the results. You can see that Houston is new. It didn't have a from population before, and now it has a to population. And Los Angeles had changed its population from this value to this value. And we know those are the only two rows that changed between those two commits. That's what this result tells us. So in this table function, all of the result columns are named after the columns of the underlying table that you're querying. So the name column becomes from name and to name. The population column becomes from population and to population. So this allows you to write arbitrarily complex queries that examine or show to your customers what changed between these two commits. And again, the commits can be anything that references a commit in Dolt. So it can be a commit hash, it can be the name of a branch, it can be this head or head tilde syntax that you're seeing here. And again, they're all modeled after Git. So anything that seems like it should work in Git should also just kind of work in Dolt or Doltgres. So that's all I got. I think we should move on to questions.